So the first thing is how this could be done within the actual ORAN network. So in ORAN Alliance, in the same specifications, there are frameworks for the signaling flows. So what nodes are involved and what signaling need to be there. So we've collected here and gathered pretty much the general aspects of those. We have the ORU that we are switching off or on parts of it, or the whole, or putting in the sleep mode. We have the E2 node that the SMO is connected to over O1 interface that gathers the measurements. And we have the non-real-time rig that is equipped with RAPs. So we are speaking in that context, in our particular scenario, about the RAPs, how we design an RAP, which is an application sitting at a non-real-time rig, to decide on switching off something. And that something could be the whole base station, or the whole cell, or the whole, or part of the RF chains. Now, the first thing we need to get is the configuration. So how many cells we have, what are those cells, what are the, let's say, configuration possibilities, how many antennas we have, and so on and so forth. So the configuration of each particular ORU need to be gathered over the collection and control and provided to the RAP. And then periodically, in some sense, we need to gather those measurements, those data, which is, for example, energy consumption, the current energy consumption, the traffic load per cell or per carrier or per beam, number of users or whatever. We gather them periodically, and then based on this, the RAPs and the machine learning training and inference takes those into account, and then, for example, predicts what will be the load in particular places in an hour, or it could learn and then create some kind of traffic profiles for each of the day. And then based on this, it could either act immediately once the traffic is getting low, or it could predict that the traffic will get low, or it will increase to make those decisions or make those recommendations to switch on and off the base station. So this is, let's say, sort of a framework of the interfaces that are involved, and we'll get into the details later on. But one more important aspect is that they cannot just work as they are, meaning that we cannot just focus on an energy-saving decision, switching on and off something. We need to take into account that the remaining traffic need to be handled in some ways. So if we have a look at the, let's say, predicted traffic profiles in the center here, and if we consider the two options, one is when the traffic is expected to be decreasing or expected to be increasing, or is measured to be increasing or decreasing. So if we take a look on the right-hand side, which is the decreasing traffic load. Now, in this context, we would like to switch off capacity cells to save energy, of course. So the energy-saving RAP would basically decide on switching off some cells. But in addition to that, it needs to take into account that the remaining users need to be secured in a sense of assuring quality of service, quality of experience. So it decides, for example, to send the traffic steering policy to the traffic steering XApp so that the handovers will be invoked, and all the users that are subject to be connected to the cells that we're going to be switched off are moved to the coverage cell. And only then it could order the capacity cells to be switched off. In contrast, if we go to the increasing traffic load, so for example, we predict that the next 2 hours the traffic will increase significantly, we should do the opposite. We could provide first the capacity to be there so that we could serve the new users that are expected to come with a good quality of service. And then we could also do both things, or we need to do both things. So switching on all the cells doesn't help as such. What we need to do is to make sure that the users that will come will be moved around those cells. So again, we need to do two things. First, we need to put the cells to the on state. And then second, we need to distribute the users to those capacity cells that will pop up.